My name is Stefan Welsen. I work as a researcher for the Institute for Production and Logistics in Bremen, BIBA, is the abbreviation. And the reason why I present you the technical parts here is partially because some of the technical results that you will see on the next slides come from a project that we concluded last year called Koala. That's the project that we coordinated on our side, and the results we transferred, and we continue improving these results in the Wasabi project. So that's why some things here will be labeled with Koala, and you will understand better in the next slides what the reason for that is. So yeah, this is the technical part of this presentation. So in the open call, as Sylvia explained, there will be some contributions from the Wasabi project to the experiments, and we expect you to use and experiment with these. Some are optional, and some are kind of mandatory to conduct the experiment. So the outline for these few slides is that I will go briefly into a slight technical view on what a digital assistant is for those that might have different ideas or not so clear ideas about it. I will explain something about a framework that we are using, an open source framework called OVOS. I will explain what skills are in this context of this framework. I would say something about a Docker Compose project that we provide as a Wasabi project to the experiments, and something about the Koala app. Okay, so we will start with the digital assistant. So what's a digital assistant? We use this kind of presentation in several occasions. Some of you might have seen it in other presentations. So a digital assistant in principle is something that we interact with through natural language, and it's a kind of software that we are interacting with here. It supports people or takes over time-consuming, stressful, or otherwise unwanted activities. Also, the assistant typically knows and does things that we associate with intelligence. That's why we often call it also a digital intelligent assistant, because we perceive it as intelligent. At the same time, it's a kind of amorphous compound technology. We coined it in the Koala project previously, because it is somewhat flexible in how it will be realized and what technologies it will include. The illustration in the lower part gives you an idea how an assistant oftentimes looks like. So it oftentimes has a component that transcribes voice into text. Then that text is analyzed further. You try to understand, computationally try to understand what the text is about, what the user wants, literally, from the assistant. And you try to recognize some key information called entities in it. And with this information, the intent and the entities, you can then apply rules, you can apply other techniques to find a fitting response from the assistant in text form. And then the last step is that oftentimes when you then want to have a voice output, audio output, you need to generate an artificial voice. So this is how it roughly works. And the green part, this is the amorphous part here on the right-hand side. This consists of everything that you need to access when you want to build the response. So that can be in the manufacturing world, that can be other information systems where you can find pieces of information that you need to puzzle together a response. You can access tools and software tools in particular here for asset monitoring, for data analytics. You can access file servers, so you have access to media and all this kind of stuff. So this is the rough setup. Now, what is missing here, and what maybe a lot of you know by now, is generative AI. With generative AI, like a GPT or something, it looks a bit different. In principle, you don't necessarily need this part of intent and entity extraction. The dialogue management is kind of embedded in these large models, large language models. So it looks different, but in principle, the working mechanism still remains the same. You need to transcribe, you need to generate voice, you need to access things in the background also to give your assistant some meaning and some functionality. Okay, so this is how we understand digital assistance. And then the question is how to realize it. And for realizing such an assistant, you have now a variety of different frameworks, software frameworks to do it. We decided to use one that is open source. That project is called Open Voice OS, OVOS, and it's a kind of voice AI platform. It is community driven, so that means there's no large company behind it, like I don't know, like a company that maintains the Neo4j graph database, for instance, or other kinds of large organizations, Google or someone. Sometimes they take ownership of the contributions to such an open source project. The focus is on Python. That's good because a lot of people can program in Python and know how to do it or can learn it quickly. It's also very transparent in this sense. And one other fact also about this OVOS project is that it looks like it's rather comparably new, but in fact it's not so new because it continues the work that was started by another project called Mycroft. Unfortunately, Mycroft had to be deprecated and is discontinued. So the people from the OVOS community took over what Mycroft built and significantly extended it also, so that it has now much more functionality, stability, and flexibility compared to the original open source project. I collected some important links here also that give you an idea about the project, the GitHub profile with a lot of repositories related to the OVOS assistant, and a technical manual which demonstrates that there's a very thorough and comprehensive technical documentation. So it's much easier to work with this kind of a project when you have a good technical documentation. So this is what we use in Wasabi for building the say empty assistant part. And now, in order to make it useful for specific applications or application cases, you need functionality. And similar to a smartphone, for instance, where you have the apps that give you functionality, in voice assistants we have skills. It's a wrapping of some functions that help you in certain situations for certain purposes. Each skill here is effectively a Python program that contains all the training data, response templates, and code to manage how the assistant should interpret what it receives from the user and how it should build the response, literally. Fill it with live, can access databases also if this is necessary for something. It can even access things like a GPT API or run other APIs for data analytics or something like that. The OVOS public repositories contain several general skills, oftentimes skills you find useful for the consumer domain, but the main point here is you can look into those skills. You can learn how they build them, how they work, and this is very helpful when you try to build your own skill. Then we have the so-called Wasabi Docker Compose project for OVOS, and this is something that is necessary because the assistants in Wasabi that we deploy are containerized. So everything runs as a stack and assembly of Docker containers, and with Docker Compose we arrange these containers and maintain them. The stack, the minimalistic stack that we have, contains only very few components. One is the OVOS core component that builds the essential part of the OVOS assistant. Then OVOS message bus, general skills that we need for very basic interactions with the assistant, a reverse proxy, an identity management solution so that you can have users literally registered in your setup, and also a HiveMind service that's a kind of extension for OVOS that gives you, in some areas, much more flexibility than the basic OVOS setup. So this is what we use, what we experiment with, what we improve over time to simplify the setup of an assistant. And then the last part I want to show is the so-called Koala app for Android. This is also an open source project that we took over or forked. It started as a Mycroft app, and then now it becomes much more centered around OVOS, and then also around the functions that you would need for having such an assistant and interacting with it in the manufacturing world. That means, for instance, that you can register users and you limit the access to the solution in some way. You can run or your assistant can answer with rich media involving text, images, clickable links, in dialogue buttons, so you can have a quick navigation during a conversation. You can have so-called SSML tags, which control the way how the app then in the end generates the voice audio output, and everything we try to deliver here as an APK file. So it's not in the Google Play Store or something. It's delivered as an APK file. Each APK file represents one version that we publish, and there's continuous development where we improve areas, where we fix bugs, of course, and also where we implement experimental features to try them out in manufacturing. So this is an optional component. It is a quick and easy way to interact with a Wasabi or OVOS-like assistant, and it can be customized because it's literally open source. So so this is these are the main parts I wanted to share here, and if there are any questions, I can answer questions, of course. Thank you.